In the previous video, I gave you some examples of some piecewise functions. So now it's your turn to have a go. So sketch is this piecewise function here. Okay, so press pause and have a go. Okay, so to do this here, well, for the first piece here, try and imagine as y equals you drawing the graph of y equals x plus 3. So this is it will have an intercept of 3, a gradient of 1 here. So so y equals x plus 3 would look something like this. Hang on. And then, but the thing is, it's only valid when x is strictly less than -1. Well, -1 is here. It's strictly less than, so it's got to be an empty circle. So hang on, it will be an empty circle like this. Okay, and anything greater than x x when x is greater than 1, it's not valid. So it's only valid when x is less than -1. Okay, now the next one is well, imagine you drawing a graph of y equals x squared. It will look like this. The origin, -1 squared would be 1, 1 squared would be this, 2 squared would be 4, -2 squared would be this. So it will be a quadratic like this. But the thing is, it's only valid for when x is equal to or greater than -1. Well, -1 is here, so it's only, well, it's going to be here. Okay, that means anything over here doesn't really count. So hang on, let me just delete this. So anything over here doesn't count, and if you look at this here, it's only x squared is only valid when x is less than or equal to 2, or 2 is here, so it's well, including the 2, it's including the 2 here. So it's going to be a black circle here. Let's get rid of anything beyond 2 here. And then the last part is when x equals 2. So this equals 2. So it's like you drawing a line of y equals 2. So y equals 2 will look like this. But it's only valid when x is greater than 2. So x greater than 2. So hang on. So it will look like this, because it's only valid when you see anything over here doesn't count, because it's only valid for x being strictly greater than 2. So strictly greater than 2 would be an empty circle like this. So your graph here would look like this. Okay. Next one here. Okay, so draw this piecewise function. So press pause and have a go. Okay, so to do this here, while looking at the first piece, just draw a graph of y equals -x. Y equals -x will look like this. Okay, but the thing is, it's only valid for x being less than 0. So anything beyond 0 doesn't really count. Okay, and well, we could include the empty circle here because it's strictly less than 0. Now for x greater than or equal to 0, it's going to be you sketching this y equals x here. So just draw a line of y equals x. It will look like this. But the thing is, it's only valid for x being greater than or equal to 0. So we've got to get rid of anything. We've got to get rid of anything lower than 0 here. Okay, and this here includes it. So now it's the black circle supersedes the white circle. So we can't just draw it as a straight line here. Okay, like this. It would be like this. Okay, because you've got an empty circle, and then later on you've got a black circle, so it includes that. So we might as well just draw a straight line like this. Okay, a line, not a straight line. So this function here, this piecewise function here, is exactly the same as f of x equals the absolute of x. Okay, you see, and don't forget this is the same as abs of x. You see, this function is the same as this function, and well, this whole thing here, this whole thing here is the same as this whole thing here. So really, this piecewise function here is exactly the same as this. It's just another way of writing it, and also is exactly the same as this. So this piecewise function here is exactly the same as this and this. It's just a different way of writing it. Okay.